Okay, having a look at a couple of solving exponential questions. I thought these were a little bit different, so I thought I would do a video on these two in particular. So when we see something like this, we use our null factor law. So we can say that either 3 to the x is equal to 0 or 3 to the x minus 27 is equal to 0. Now, if we've got 3 to the x equals 0, we can't solve that. So that one is undefined, and we go over here and have a look at that one instead. So we can change that to 3 to the power of x is equal to 27. And now we can solve it because we can write 27 is 3 to the power of 3, and then equate the indices, so x is equal to 3. So in this case, we've only got one solution. Down here, we've got 2 to the power of 2x minus 2 to the x plus 1 equals 0. So it's looking like it could be a quadratic. So if I write 2 to the x, and raise that to power of 2. And then here I can actually split them and make it 2 to the power of x. And then we've got being multiplied by 2 to the power of 1 would give us the 2 to the x plus 1 there that we want. And so we can actually write 2 to the power of 1 is just 2. So we've got 2 times 2 to the x. And we've got our 2 to the x squared equals 0. So we can treat that like the quadratic. And I have another video similar to that with the quadratic. So what I'm going to do is let a equal 2 to the power of x. So what I've got is a squared minus 2a is equal to 0, and I'm going to factorize that, and it's a nice quick one to factorize, so I can just take the a outside and I get a minus 2 equals 0. So therefore a must equal 0 or a minus 2 is equal to 0, which would mean a is equal to 2. Now I need to go on then and take that back to where I had the 2 to the power of x. So I've got either 0 is equal to 2 to the power of x, which we've already talked about, we can't get a solution for. So then we can come up here and say, well, if 2 is equal to 2 to the power of x, then that means that our x must be equal to 1. So that we get our solution there for that one. So hopefully that is helpful with your solving exponentials and how to approach those ones that are a little bit different to the norm.